Next question is 2.32. Show that the circumference of the Bohr orbit for hydrogen atom is an integral multiple of de Broglie's wavelength associated with the electron revolving around the orbit. So here what they're trying to say is, when you take the circumference of the Bohr's orbit, that has to be of a hydrogen atom, that has to be an integral multiple of de Broglie's wavelength associated with electron that is there around the orbit. So here, since both of these are asked, we'll solve one by one. So since they are asking about Bohr's orbit, let's write according to Bohr's postulate of angular momentum, mvr is equal to nh by 2 pi. So this is the formula. Now m is what? M is going to be the mass of electron. V is going to be the velocity of electron. Then you're going to have R, which is the radius of orbit in which the electron moves. N is going to be the orbit, in which orbit it is. H is going to be Planck's constant. So these are the terms that are mentioned in the formula. So here I can rearrange this formula and I can write 2 pi r equals nh by mv. This is the formula and I will name this formula as formula number 1. Now what is this on the left hand side? 2 pi r is nothing but circumference. So I can say that 2 pi r over here is the formula of circumference. That's why I have interchanged the entire formula, because in the question it's clearly told you have to check that the circumference of the Bohr's orbit. So I rearranged the formula in such a way I got the circumference here. Okay, so that is for circumference. Then the next question asked in this is de Broglie's wavelength. So here when I write for de Broglie's wavelength, I can write that according to de Broglie's wavelength, lambda is equal to h by mv. Now here lambda is nothing but wavelength, h is again Planck's constant, m is mass of electron and v is velocity. So this is going to be my equation number 2. Now what I'm going to do is I'm going to compare equation 1 and equation 2. When I compare equation 1 and equation 2, what is common? H by mv is common. So leaving that aside, I'm going to equate equation 1 and equation 2. So here I'm going to do substitute equation 2 in equation 1. So wherever I have h by mv over here, I'm just going to put lambda. So there I will get 2 pi r is equal to n lambda. So here when you see the equation, it is clearly what it is written here. Circumference of the Bohr's orbit of hydrogen atom. Circumference of the Bohr's orbit of hydrogen atom is this. This is a circumference formula. It should be an integral multiple. N is an integral multiple of de Broglie's wavelength. Your de Broglie's wavelength is this lambda. So here you have already proved this particular formula. So thus we can say that circumference of the Bohr's orbit of hydrogen atom is an integral multiple of de Broglie's wavelength. We can write that statement here. Thus the circumference, which is 2 pi r of the Bohr's orbit for the hydrogen atom is an integral multiple of de Broglie's wavelength. So here it is already proved in this case.